So I wanted to explain why we did not use direct substitution this last one and why we had to use canceling out a common factor. So you're going to have to know your factoring again. So the reason why we could not use direct substitution, if I would have done that, I would have gone 1 minus 1 all over 1 squared minus 1. I would have gotten 0 up here. I would have gotten 0 down here, and I cannot divide by 0. Whenever you can use direct substitution as long as you don't end up having to divide by 0. So we could not choose to use that method. So you have to choose a different method other than direct substitution. So now I'll come over here. The same thing is going to apply in this problem here. I cannot use direct substitution because if I put 0 in there in the denominator, I'm going to end up dividing by 0, and I can't do that. So I might have to go ahead and just simplify this whole thing out. So then I have to remember what that 3 plus h squared is. I could FOIL that out. I could see that as a difference of squares. If I saw that as a difference of squares, I could do that. But I'm going to go ahead and FOIL this out and see if that works for us or not. So the limit as h approaches 0, FOILing that out, 3 times 3 there is 9, plus 3h, plus 3h, plus h squared, minus 9, all over h. So I'm going to keep going. I'm looking up there in my numerator there, and I've got h squared. I'm going to put them in the right order. 3h plus 3h there is 6h. And then I realize, oh, that 9 minus 9 is just going to cancel out, and it's all over h. I'm going to also notice that, oh, that numerator has a nice GCF of an h. So I'm going to pull that out, so I'm left with h plus 6, and then all divided by h. So the first term here, they both have an h here in common. The first two terms there, I pulled the h out. H times h gives me h squared. H times 6 gives me 6h. So now I can see that the h's there cancel out. Now I can substitute 0 in there. So 0 plus 6, which gives me a limit of 6. So I couldn't directly plug in 0 because I would have gotten 0 down in my denominator. So couldn't use direct substitution, had to FOIL that whole entire thing out, saw that the h terms canceled out, then I could go ahead and substitute 0 in there. I got a limit there of 6. Find a limit by rationalizing. So notice you've got a square root. So that's not very helpful. It's not like you can take the square root of x squared and square root of 9 there. They're attached by addition. It's not like if you had square root of 9x squared, sure, we could take the square root of that. That would give us 3x. But that's not what they gave us. They gave us x squared plus 9, the square root of that. So what we're going to go ahead is we're going to rationalize the numerator there. To do that, we have to multiply both the numerator and denominator by x squared plus 9 and then plus 3. The same term as the first term there. It's that second term. It's not a minus 3. It's going to be a plus 3. So then I'm going to have to multiply down here by the same thing. So now you're going to have to FOIL out your numerator there. And no, you could not use direct substitution in that one because you would have gotten 0 squared, which gives you 0 down in your denominator, and you couldn't divide by 0. So let's go ahead and let's FOIL this out. The square root of x squared plus 9 times the square root of x squared plus 9 there, when you multiply those, you end up canceling those two out. So you just get x squared, you end up canceling out the square root part there. And so we've got middle terms there, but notice what happens with the middle terms. If I were to write it out, it'd be 3 times the square root of x squared plus 9 plus 3 times the square root of x squared plus 9, and they're going to be the same term, or like opposite terms there. So I got a minus 3 times 3 there gives me a minus 9 all over x squared times square root of x squared plus 9 plus 3. The middle terms there are going to end up canceling out, and even the 9s in this case end up canceling each other out. So the limit as x approaches 0 there, we've got x squared all over x squared times the square root of x squared plus 9 plus 3. Notice what's going to happen now. The x squareds cancel out, and I'm left with a 1 up here. So now I have the limit as x approaches 0 of 1 over the square root of x squared plus 9 plus 3. So now I can go ahead now and use direct substitution and substitute 0 in there for my x. So I'm going to do that. So inside that square root there, I'm going to get the square root of 9 there. Ends up being 3, and 3 plus 3 there is 6. So I end up getting 1, 6 when I put 0 in there. So my limit ends up being 1/6. Again, we couldn't just substitute 0 in the beginning one. That would not have worked. But notice what we did. We rationalized the numerator there by multiplying it by its conjugate. So square root of x squared plus 9 or plus 3 there, and multiply both the numerator and denominator by that. So there is the methods that we talked about using. We could use direct substitution as long as we don't get 0 in the denominator. If that's not working, we're going to have to work for one of these other three things. Either factoring and canceling out common factors, or simplifying and canceling common factors. So in other case, r is a number 3 there. We folded out, simplified it, and then canceled out our common factors. Fourth one, especially if you've got a square root here, you want to rationalize the numerator, or you might have to rationalize the denominator and cancel out your common factors. So again, the limit of a quotient is the quotient of the limits, and you cannot have a 0 down the denominator. The limit cannot be 0. So we could use these different methods in order to figure out quotients. So let's go through a couple of these and see if we can do these now. So they're all kind of mixed up here. I can't just put 3 in there, because if I get 3 in the denominator, I'm going to get 0. So 3 squared minus 9 there would give us 0. So I'm going to have to use something else. What method do you see to use? Can't use direct substitution. I bet you there's a square term in here, so I bet you'll have to use factoring. So I'm going to factor this. So I'm seeing, oh yeah, that's a difference of squares. X plus 3, x minus 3. That x minus 3 and that 3 minus x are very similar to each other. They just have a 1 there in common, a negative 1. So I could rewrite this as negative 1 times x minus 3, because if I were to distribute that negative 1 through, I get a negative x plus 3, or a 3 minus x, which is exactly what there is at the top. So now I can cross out the x minus 3 there, and I get the limit as x approaches 3 of negative 1 all over x plus 3. So now that I have that, I can use direct substitution, and I can say negative 1 all over 6, because I placed 3 in there. So negative 1/6. Using, I saw I could factor that. I canceled out my common terms, and then I directly substituted in the value. All right, this one here looks very similar. I'm thinking, oh, another squared thing. I can't directly substitute 7 in there because I'll get 0 in my denominator. So I'm going to go ahead and see if I can factor my denominator. Oh yeah, that's the difference of squares again. Plus 7 and a minus 7. So this time, my x minus 7's just cancel out. So I end up getting the limit as x approaches 7 of 1 over x plus 7. So now I can substitute 7 in there, and 7 plus 7 there is 14, so I get 1/14. Again, couldn't use direct substitution, started thinking about one of the other three, which in this case was factoring. Same with this one. Can't use direct substitution. If I put negative 1 in my denominator there, I'm going to get 0. So let's think about maybe using some more factoring, because I'm looking at that one thinking, oh, it's a quadratic again, so let's factor this. Up to you how you want to do this. I like to use guess and check. What times what gives me 2x squared? That'd be 2x times x. What times what gives me 5? It'd be 5 and 1, and I got to be careful where I put them. I'm not sure if they go here or here. And I know they both have to be pluses. Those 1 and the 5 might be reversed. So I'm going to check the inners. and the outers, and they do end up adding to give me 7x. So there it is factored. So I can see I've got my common term. They cross out. I'm left with the x, the limit of 2x plus 5 as x approaches -1, and now I can directly substitute -1 in there. So I get -2 plus 5, which gives me 3. And then remember these. Sometimes if you got a cube here, you're going to have to use that. So I can't use direct substitution, so I'm going to see that this 8 here is like 2 to the third. So that's matching this first formula up here, where my x here is a, and my 2 here is b. So I'm just going to plug them right in there. So to do that, I get x plus 2 times x squared minus 2x plus 4 all over x plus 2. Notice the numerator and denominator have that common factor of x plus 2's. They're going away. The limit as x approaches -2, I'm left with x squared minus 2x plus 4, but now I'm going to substitute my -2's in there. And when I do that, I end up getting 4 plus 4 plus 4, which gives me 12. So I've got a limit of 12. Again, I can't use direct substitution. I'm going to have to rationalize my numerator. So I'll have to multiply the numerator and the denominator by the square root of x plus 4 minus 2. So doing that, I can FOIL this out. X square root of x plus 4 times the square root of x plus 4, they cancel each other out, so I just get x plus 4. And then I get a plus 2 times square root of x plus 4 minus 2 times square root of x plus 4 minus 4 all over the square root of x plus 4 minus 2. Notice what happens with those middle terms. They're gone. The 4 minus the 4, they're gone. So I'm left with, as approaches 0, so I'm going to plug 0 in there, so I get 0 because I'm left with an x up here, and down here I've got 0 plus 4 minus 2. So square root of 4 there is 2. So when you go too fast, sometimes you make errors. So I'm going to come back up here because what did I forget? I forgot my x, didn't I? There should have been an x still down here. So now I'm going to plug my values back in here. I'm going to rewrite it. So x all over x times square root of x plus 4 minus 2. And now the x's cancel out. So I get the limit as x approaches 0 of 1 over the square root of x plus 4 minus 2. So yeah, just use direct substitution, and you end up getting zeroed on your denominator there, so does not exist. So we did as much as we could, and we still couldn't get the value. This one here, I'd get a common denominator. And so up here, I've got an x minus 1 plus 1 over 1, and I need a common denominator, so I'm going to make this x minus 1s divided by x. So now I got 1 plus x minus 1 up there, so that cancels out the 1, so I get x over x minus 1. I'm going to change this into a multiplication problem, so times the reciprocal of the denominator, so I get 1 over x. Notice what happens. These are going to cancel out, and I get the limit as x approaches 0 there of 1 over x minus 1. Substitute 0 in there, so I end up getting -1. So again, got a common denominator multiplied by the reciprocal, and then things canceled out, and we're good.